Welcome to The Explainer. Today, we're going to talk about a technology that basically acts like a DVR for your data, NATS JetStream. It's kind of the secret sauce that keeps a lot of modern applications running smoothly, especially when things go wrong.
So, to really get why this matters so much, we have to start with a really fundamental question, one that pretty much every communication system has to deal with. What happens if you send a message, but no one's actually there to receive it? I mean, where does it go?
Okay, let's start with the basics. Think of the core and NATS messaging system like a live radio broadcast. It's super fast. The signal goes out, and anyone who's tuned into the right station hears it instantly. It's incredibly efficient, as long as you're listening live. But, and this is a big but, here's the catch. If your radio is off, maybe it's getting upgraded, maybe it just crashed, you miss the song. It's gone. Poof. Forever. And for a software service, being offline for even a split second can mean a critical piece of data is just lost completely. This idea, this dependency on everything happening at the exact same time, has a technical name. We call it temporal coupling. It basically means the sender and the receiver are handcuffed together in the exact same moment in time. And for modern apps that need to be up and running 24/7, that's a huge, huge problem. So you can see the dilemma this creates for developers, right? How in the world do you build a truly reliable system? I'm talking about things like financial transactions or critical medical alerts. If your messages can just vanish into thin air. Well, the solution is to just completely change the way you think about it. Instead of a live broadcast, what you really need is a DVR. You record the show, and then anybody can watch it whenever they're ready. And that is exactly what NATS JetStream does for your data. This gives us what's called temporal decoupling. JetStream completely breaks that link between when a message is sent and when it's received. A publisher can fire off a message on Monday, and a consumer can come online and pick it up on Tuesday. No sweat. So, how does this actually work under the hood? Well, a message goes on this little three-step journey. First, a publisher sends a message, but it doesn't just fire and forget. It gets an immediate confirmation back. We call it a pub-ACK that says, yep, we got it, it's safe. Then, that message is stored in this durable, ordered log called a stream. And finally, for extra safety, that stream is automatically copied across multiple servers. And you actually get to decide how many copies or replicas of your data to keep. A really common and super robust setup is to have 3 copies. Now, this is where the real power of replication kicks in. It lets you build a system that can handle major failures. I mean, think about it. Even if 2 out of your 3 servers completely go down, your data is still safe. It's still accessible from that one remaining copy. Your application just keeps on chugging. Okay, so the data is stored safely inside this thing called a stream. Great. But how do our applications actually get to it? Well, this is where another really powerful concept comes into play, and it's called a consumer. And a great way to think of a consumer is like a smart, customizable window into that stream of data. See, a consumer isn't just a passive listener. It's this intelligent pointer that actually lives on the server, and this is the critical part. It's the one that keeps track of which messages your application has already seen. This is huge because it means your application code can be way, way simpler. It doesn't have to worry about keeping track of its own state. Let's make this a little more concrete with an example. Imagine you have one single stream, and it contains all of your company's data just flowing in. You've got orders from the US, inventory updates from Europe. It's all just mixed together in one big, efficient log. Now, here's where it gets really powerful. A consumer can act like a super precise filter. So your US orders application, which only cares about US orders, it creates its own consumer. And that consumer is like its own private little window, showing it only the messages that match orders.us. Meanwhile, at the exact same time, a totally separate application, let's say for your European inventory, can create its own consumer on that very same stream, and it pulls only the data it needs. So you're storing the data just once, but you're using it in all these different tailored ways. It's incredibly efficient. This whole idea of putting the intelligence on the server side is a real game changer. The filtering happens on the server, so you're not wasting bandwidth. The server tracks progress, so your client apps are a lot simpler to write. And, as we're about to see, it even handles spreading the work out for you automatically. For example, let's say your app is processing 100 messages, but it's starting to fall behind. What do? Well, all you have to do is launch a second copy of your app and point it at the exact same consumer.
JetStream will automatically split the workload right down the middle. Now each one is just handling 50 messages. You've instantly doubled your processing power without changing a single line of code. So let's pull all this together. These core features, they translate directly into huge real-world benefits. Temporal decoupling means your services can go offline for upgrades without losing any data. Replication, which uses a consensus protocol called Raft to make sure all the copies stay in sync, gives you high availability right out of the box. And these smart consumers give you really efficient filtering and simple automatic load balancing.
Really, the key takeaway here is this. JetStream isn't just another thing to add to your already complicated tech stack. It's a fundamental simplification. It lets you replace a whole bunch of older, complex technologies for queuing, for storage, for distributing work with one single, simpler system.
So the next time you use an app that just feels completely seamless and reliable, it's worth asking yourself, is the technology behind this thing actually built to last? Is it designed to never miss a beat and to never, ever lose a message? Because that, right there, is the fundamental problem that a system like NATS JetStream is built to solve.